Hello, good morning students. My name is MS Abdul Rasool, lecturer in chemistry in Vignan Cooperative Junior College. Today we are going to discuss about the haloalkanes and haloarenes conversions from one compound to another compound. Right, understand? Students, we are going to start conversions in haloalkanes and haloarenes. Here in these conversions, first conversion is ethanol is converted into but1-ine. But1-ine. So, ethanol formula you know very well. CH3CH2OH. This CH3CH2OH ethanol is heated with thionyl chloride SOCl2 in the presence of pyridine. Then you will get here ethyl chloride CH3CH2Cl. CH3CH2Cl. This is the ethyl chloride. Okay. Ethanol is heated with sulfonyl chloride. In the presence of pyridine. Then you will get as a byproduct SO2 and HCl are the byproducts, right? Ethyl chloride is obtained. Then acetylene is heated with acetylene formula CH triple bond CH. Students, let us discuss about the conversions, organic conversions in haloarenes and haloalkanes chapter. In this chapter, first conversion is ethanol to but1-ine. Ethanol formula you know very well. CH3CH2OH ethanol is heated with thionyl chloride SOCl2 in the presence of pyridine. Then you will get what ethyl chloride, right? Then again you have to take one more compound, acetylene. This acetylene is heated with sodium metal in the presence of liquid ammonia. Then you will get here CH triple bond CNA. Sodium acetylide is formed. This sodium acetylide is treated with ethyl chloride. Sodium acetylide is treated with ethyl chloride CH3CH2Cl plus Na C triple bond CH. This one is the sodium acetylide, and this one is ethyl chloride. Right, understand? What will happen here? This NaCl goes out as a byproduct. Then you will get CH3CH2 C triple bond CH plus NaCl as the byproduct. You will get here but1-ine. In this way, we have to convert the ethanol to but1-ine. This is the important conversions. One organic compounds, one molecule is converted into another molecule. Either may be two or more than two steps, but reaction conditions must be essential. Right, understand? And the second conversion, ethane to bromoethene. First of all, you have to take ethane molecule CH3CH3. This one is the ethane. This ethane is heated in the presence of UV light at 573 to 673 kelvins of temperature. Then you will get here ethyl bromide CH3CH2Br plus HBr. This is the simple substitution reaction takes place between the ethane molecule. In ethane molecule, simple substitution reaction takes place because ethane is the water saturated hydrocarbon. Then this ethyl bromide is heated with alcoholic KOH. Alcoholic KOH is the reagent which is used for dehydrohalogenation. Then you will get here CH2 double bond CH2, dehydrohalogenating reagent. Halogenation will be takes place. So ethylene is formed. This one is the ethylene. This ethylene is again reacting with water bromine in the presence of CCl4. Then you will get here Br CH2 single bond CH2 Br. The name of this compound is 1,2 dibromoethane. This dibromoethane again heated with Br CH2 single bond CH2 Br is heated with again alcoholic KOH. Alcoholic KOH is the reagent which is useful to remove the dehydrohalogenation. Hydrogen and halogen will be removed. Then what will happen here? CH2 double bond CHBr is formed plus HBr. So this bromine atom and the H atom of this one goes out as SBr. Then you will get here bromoethane is obtained. So there is a conversion from ethane to bromoethane takes place. How many steps you have to understand about it? This will be you can learn very easily by learning the properties of the compounds. Without knowing the properties and preparations of organic compounds, then you are unable to convert the one molecule into another molecule. By learning all the concepts and preparations and properties, then you can easily convert the one molecule into another molecule. In this conversion, ethane is converted into bromoethane by the following reactions. Ethane is first treated with bromine. We have to convert it into ethyl bromide. This ethyl bromide is there. Then we have one bromine atom and one hydrogen atom. This can be removed by alcoholic KOH. Alcoholic KOH is the reagent to remove it is used for dehydrohalogenation reagent. Right? Then you will get ethylene is the double bond compound. Again you have to add bromine to get 1,2 dibromoethane. This 1,2 dibromoethane will be again treated with alcoholic KOH. Then we will get bromoethane. What we have desired product from ethane. Right? Understand? Here the third conversion is propene to 1-nitropropane. Propene formula, you know it, CH3 CH double bond CH2. This is the alkene. Which type of alkene? This is the unsymmetrical alkene. This unsymmetrical alkene reacts with HBr, HBr in the presence of peroxide, in the presence of peroxide, right? Peroxide, peroxide effect is there, follows the anti-MK rule, anti-MK rule, then we will get here CH3, CH2, CH2Br is the major product. One bromopropane is the major product, right? Understand? This 1-bromopropane again reacts with CH3, CH2, CH2Br. 1-bromopropane is reacting with silver nitrate, AgNO2, and ethanolic silver nitrate. Ethanolic silver nitrate, then you will get here CH3, CH2, CH2NO2. So this is the 1-nitropropane is obtained. 1-nitropropane is obtained. When it happens, when propane is reacting with the HBr in the presence of peroxide, peroxide effect is takes place, follows the anti-MK rule. That means negative part of the addendum goes to the double bonded carbon atom which has more number of hydrogen atoms. Then we will get 1-bromopropane. This 1-bromopropane is 1-bromopropane. 1-bromopropane is reacting with silver nitrate, ethanolic silver nitrate. Then you will get 1-nitropropane is the major product, right? Understand? This is the conversion of propane to 1-nitropropane. Propane to 1-nitropropane, right? Next, fourth conversion is toluene to benzyl alcohol. You know the formula of toluene, benzene ring, it has one methyl group. This toluene is heated with chlorine at 773 kelvins of temperature. Side chain chlorination will takes place. We will get here benzyl chloride. Benzyl chloride is formed. This benzyl chloride is heated with aqueous KOH, not alcoholic KOH. Aqueous KOH is always a substitution, will be takes place, nucleophilic substitution. Then you will get here benzyl alcohol, CH2OH. This one is the benzyl alcohol, and this one is benzyl chloride, and this one is your toluene. Toluene is heated with chlorine at 773 kelvins of temperature. Side chain chlorination will be takes place. Then you will get benzyl chloride. Benzyl chloride is heated with alcohol, aqueous KOH. Then you will get benzyl alcohol. Right? Understand? Next conversion, fifth one is propene to propine. How we are going to convert this propene to propine? First of all, I want to write the propane formula, CH3CH double bond CH2. This propane is halogenation will be takes place Br2 in the presence of CCl24. Then you will get CH3CHBr and CH2Br. Right? Understand? Then what will happen here? Again, how to this one reacts with alcoholic KOH. Alcoholic KOH is the one of the most important reagent, dehydrohalogenation. This Br, this and H will be eliminated. Then double bond is formed. This Br and H, both Brs are eliminated. dehydrohalogenation takes place minus 2HBr. Minus 2HBr. Then we will get here CH3 C triple bond CH. CH3 C triple bond CH. Here this one is what propine. Propine. This is the simple conversion. Propene is subjected to bromination. Then addition will be takes place. What addition is takes place here? Nucleophilic electrophilic addition. Electrophilic addition is takes place. Then you will get here 1 comma 2 dibromo. 1 comma 2 dibromopropane is obtained. 1 comma 2 dibromopropane is obtained. When propane is reacts with propene, it reacts with what? Bromine. Propane reacts with bromine in the presence of CCl4. Then you will get 1 comma 2 dibromopropane. This 1 comma 2 dibromopropane is again heated with alcoholic KOH, which is the used as a dehydrohalogenating reagent. Then we will get the desired product is what? Propine. Right, understand this conversion? Bromomethane to propanone. How we are going to convert it? First, bromomethane formula CH3Br. This CH3Br is treated with methyl cyanide. No, KCN. KCN, I have to write it. KCN, alcoholic KCN. Then we will get here methyl cyanide is formed. Triple bond N. Again, this is heated with methyl magnesium bromide, which is said to be Grignard reagent. Methyl magnesium bromide, which is said to be Grignard reagent. CH3 CH3 double bond NMgBr. So followed by hydrolysis. Then what will happen here? Here O, here H2, here H, and here OH. Then you will get here CH3 C double bond O CH3 plus NH3 plus MgBrOH. So this is the propanone. Propanone is obtained from methyl cyanide. Right, understand? Methyl bromide. First, methyl bromide is treated with KCN, alcoholic KCN. This Br is replaced with cyanide. This is the nucleophilic substitution reaction. Then we will get methyl cyanide is obtained. This methyl cyanide is treated with methyl magnesium bromide, which is said to be Grignard reagent. Then the addition compound is formed. This addition compound is subjected to hydrolysis. Then you will get out a propanone. Right, understand? Next conversion is but1en to but2en. But1en formula I can write here CH3 CH2 CH double bond CH2. This is the but1en. But1en is subjected to HBr. Addition of HBr follows the MK rule. MK rule. Here this is the unsymmetrical alkene. This unsymmetrical alkene, addition of HBr takes place. This Br atom is the attached to the double bonded carbon atom, has least number of hydrogen atoms. So Br goes to second carbon and H goes to first carbon. Then we will get here product CH3 CH2 CHBr CH3. This is the 2 bromo butane. 2 bromo butane is obtained. Then again this compound is subjected to alcoholic KOH. Alcoholic KOH is the reagent. Which is used for dehydrohalogenation. Will be takes place. So here what will happen? Br and H, this H is possible is there, and Br and this H is also possibility is there. According to Sitgif rule, the double bonded carbon atom containing more number of alkyl groups is the more stable alkene, which consists of more number of alkyl groups. So the HBr goes from this hydrogen and this Br. Then we will get here product CH3 CH double bond CH double single bond CH3. Suppose this Br goes with this hydrogen, then we will get here the product is CH3 CH2 CH double bond CH2. This is the 1 bromo 1 butene. This one is the 2 butene. 2 butene is the major product, and this one is the minor product, is also formed minor product. Why it is a minor product? Because it is not a stable one, but this one is the more stable, because this double bonded carbon atoms contains, this carbon contains one alkyl group and this carbon is also another alkyl group. Therefore this is the more stable. So conversion of 1 butene into 2 butene like this compound is not formed. Right, understand? This is the conversion of 1 butene to another 2 butene. Right? Third conversion is 1 chlorobutane to N-octane. How is it possible to convert the 1 chlorobutane into N-octane? So I want to write the first formula. 1 chlorobutane CH3 CH2 Cl. This is the 1 chlorobutane. I want to take 2 moles. These 2 moles of 1 chlorobutane is heated with sodium metal in the presence of dry ether. Dry ether is the reagent. So alkyl halide reacts with the sodium metal in the presence of dry ether. What is the name of this reaction? The name of this reaction is Wurtz reaction. Why? Because alkyl halide reacts with the sodium metal in the presence of dry ether is said to be Wurtz reaction. Wurtz reaction is useful to prepare the higher alkanes. So I will write here the name of reaction is Wurtz reaction. So what will happen here? This chlorine and sodium goes out as a NaCl. Right, understand? Then we will get here these alkyl groups are attached to each other. So CH3, CH2 taken 6 times CH3. N-octane is obtained. N-octane is obtained plus 2NaCl. By means of Wurtz reaction, one can prepare the N-octane by using the 1-chlorobutane. 1-chlorobutane is subjected to Wurtz reaction, then you will get N-octane. N-octane means a normal chain octane. No branches are present. Right, understand? No branches are present, then we can say it is said to be N-octane. N-octane means here 1 carbon, here 2 carbons, and here 6. Totally 8 carbons are there. So that we can say it named as N-octane. Right, understand? The conversion of 1-chlorobutane to N-octane by Wurtz reaction. So what is the general equation for Wurtz reaction? 2Rx, 2Rx plus 2Na in the presence of dry ether, then you will get R plus 2NaX. Right, understand? Here one alkyl group, here another alkyl group attached to each other to form a higher alkanes are prepared. Right, understand? Symmetrical alkanes can be prepared, but Wurtz reaction is not at all useful for what odd number of alkanes are not prepared by this method. If two alkyl halides are different to one another, then the mixture of alkanes are obtained. Therefore, symmetrical alkanes can be prepared by Wurtz reaction. Right, understand? Fourth conversion, benzene to biphenyl. First of all, we have to write benzene molecule like this. Benzene molecule has 3 alternative pi bonds. This benzene reacts with bromine in the presence of FeBr3. What will happen here? Electrophilic substitution reaction will be takes place. Then you will get here bromobenzene. Bromobenzene is obtained. Right, understand? Okay, it's all right. This bromobenzene again reacts with sodium metal, 2 moles of sodium in the presence of dry ether gives biphenyl. Biphenyl means two phenyl groups are attached to each other. Two phenyl groups are attached to each other. Right, this is the biphenyl. What is the name of the named reaction is takes place here? Fatigue reaction. Fatigue reaction means here bromobenzene is heated with 2 moles of sodium. Bromobenzene is heated with 2 moles of sodium in the presence of dry ether gives biphenyl. This is the very important name reaction. So this bromobenzene can be obtained from benzene. What is asking here? So how we will convert the benzene molecule into biphenyl? Benzene molecule, first of all, we have to subject it to electrophilic substitution reaction in the presence of Lewis acid FeBr3. Then you will get what a bromobenzene. This bromobenzene is again heated with what a sodium metal. Sodium metal in the presence of dry ether. Then you will get what a biphenyl. Biphenyl. This name reaction is said to be what a fatigue reaction. Right? Understand? Fatigue reaction.